Co, and welcome to the weather briefing in March from the training center of Deutscher Wetterdienst in Langen, near of Frankfurt. I think you know the location. And today we will play for you the ice weather sound in relation to the extreme cold March in Germany and other parts of Europe. And some days before, around about 2 weeks, it would be possible that we arrange such a ice concert also here in Frankfurt area because we had a very strong frost period. I will show you this later. But the original place for this festival is in Norway, not in Germany. Today we are an orchestra with 7 members. My colleagues, they are sitting here in the room, are young and fresh from university. And I'm sure in round about 1 year they are forecaster for aviation and also for general weather warnings. And we share us, the speakers are also Arne and Philipp. And at first I'll give you some overviews. One moment. Our topics today are at first a short looking back to the winter month, March, and also the month before. The second topic is a dust outbreak over Africa. We had in the last weeks a lot of dust outbreaks. Perhaps you see it also in television, and we give you some satellite aspects. The third point is we show you the lake effect over the Baltic Sea in relation with the cold air outbreak. And the last points are a short view to the weather today and outlook to Easter. What will happen there with the weather. At first, please mark in the right Europe card where do you come from, and on the left part, what is your current weather situation. Now there are coming more information. Yes, okay. Okay. So the many comes from Italy, Southeast Europe, Poland. Nobody from the northern countries. And mostly have cloudy conditions, a little statistic here. But some are here from Langen and we have cloudy weather. So, okay, good, thank you. So we are looking back to the last month, and these are impressions from March. We had cold easterly winds, snow, and these are in different parts in Europe, in Rome, in London or Berlin area. And here you see the seasonal mean for the 3 winter months, December, January, and February. On the left image, it's the seasonal mean for all months. And if you look to the area, I hope you see my mouse as a cursor. There is the same, you see in the southern part, the same color for the temperature as, for example, in East Poland or Eastern Europe. So it's the first hint, it was really warm in the Arctic regions. And on the right image, there are difference to the to the temperatures for the period 61 to 90, the WMO period, and you see it was dramatic to warm in the Arctic region, more than 6 degrees to warm, but also in some parts of Europe. It was not so cold for the whole winter in the central part of Europe. In the eastern part it was a little too warm, and only a little too cold in the Iberian Peninsula and in Great Britain, but not much. And this is a more detailed looking to the month from January. You see in January it was strong to warm, around about 5 degrees. This is, you see here different lines. They are all from the area in Frankfurt, Darmstadt, Frankfurt, and some other stations. And in the February, you see there was, it was in the summary round about 2 degrees too cold. And the main reason is the first part of cold air attraction here in Germany at the end of February. And in March, I had only up to the 25 March, not the last days, but the last days are not so, I think, more a little too warm. But you see here the second cold period, it begins round about from the 17th March. And from this period, you will see later some images and some impressions from the Baltic Sea. Yeah. So now we make a short break. Arne will now come and will present you some information about interesting dust outbreaks.
From my side again, I'm Arne. Do you ever hear me? Okay, so I will present some slides of the dust outbreak over Africa, and we'll focus on the dusk RGB composite image from the satellite Meteosat image. First of all, I will give a little presentation about the synoptic situation which triggered the dust outbreak. And as you see in the 4 charts, it's the upper chart is upper left, you have the medium sea level pressure and the 2-meter temperature, and it's right there at the Moroccan and Algerian border. You see the cold front lying there, which is good visible in the temperature gradient there. And as well in the Theta E chart in the lower left, also in the Omega chart in the lower right. And the upper right just represents the large-scale situation with the trough over larger parts of Europe till North Africa. That's for the synoptic situation. And the cold front is triggering the dust outbreak. So this is the satellite image from Friday, the 16th of March at 12 UTC. And you see a small pink dot here. That's the Wadi Dra, so it's a dry valley in which the dust outbreak first starts, the first dust starts. And it's in the south of the Atlas Mountains, which are where the cold front is lying. Yeah, just for a few features in the satellite image, what you see in the upper left corner, it's those black streams. They are perpendicular to the jet streak, which will be better seen in later images, and I will show in a second. The big red patches in the middle and also in the northern part, there are it's thick, high ice clouds, and in the middle part, the green patches, those are thin cirrus clouds over the desert. Yeah, another feature you can see is the more humid air in the coastal regions, which is the darker shade of blue compared to the very pale or light shade of blue inland, where it's really dry because it's a desert. Yeah, exactly. Another thing, the really pink patches or the plume, the dust plume, which I mentioned before, can be seen here where the mouse is. Those in the right-hand side in the picture, those patches, they are not dust. It's just because of surface warming by radiation that there are some over or error signals in the image, so they will go away in the night, or will be less seen at night. Yeah, that also the brown area here, it's mid-level, around 700 APA air clouds, or clouds, yeah, air clouds, of course. Yes, that's about this. So this is a video, and just to see how the outbreak happens, I will play it now for you. And you can see as the plume start, it's stationary plume, and then it's with the front, the downburst, or the winds from the front, it starts moving or spreading across Algeria. Enjoy for the next few seconds. Okay, so that's so much for the outbreak. What you can see now, like the shade of the image really changed. It's a little warmer colors. If you go back to the first image again, it's really very bright colors, like the blue on the land. And if you see the very end of the video, you see the warm colors, which is really characteristic for the dust RGB if you have images from night time, so at night. And the end was from 3 UTC on Saturday, 17th of March then. So now to go to a little more to some characteristics of or look a little more at the dust outbreak at all. So we see here it started at 12:15 UTC in the upper image. We see the first warning here with this dollar shape or signal. It's for the weather signal for a sandstorm or blowing sand or drifting sand. So we see there's some wind and a lot of dry sand which can be moved by the wind. And if we go to the next image below, it's from 3 hours later at 3:15. Then you see the first contours of the outbreak and the cold front trigger dust storm, or even this station here in Beni Abbes, which is 500 meters above ground. It reported 360-degree winds, so northern wind, and 35 knots, which is quite some wind, and it coded the WW31 symbol, which stands for sandstorm, and it also reported a visibility of 0 kilometers, which means just below 1 kilometer, and so it's really no good visibility and a lot of sand. Again, on this image, you see the jet fibers here. There's perpendicular to the jet stream, which lays in correspondence with the trough I showed before over the Atlantic Ocean, and thus hitting the coast and then bending with towards southern Europe again. Then we have 2 more images of the spreading front, of spreading dust outbreak, and you see the sands, also the weather stations there, they all reported sandstorms or drifting and blowing sand, and also not good visibilities. They all have been around or below 1 kilometer, and below 1 kilometer, and even in the late at night, they still have some stations report really the blowing and drifting sand with visibilities right below 500 meters. Some even reported below 300 meters. So, okay, then now a short quick quiz for you. Which one of the images is taken at night? So I should give you the rights to annotate, and now just put your pointer to what you think, which image is taken at night. Okay, first answers are getting in, and they're quite evenly distributed. So maybe I wait for some other answers. They're still evenly distributed. Okay, so thanks for all the votes or the cast of votes, and I'll give you the solution now. And so I have to, sorry, wrong button. And so the solution, and the upper one is at night, where you can definitely see the warmer colors, especially in the area over Libya, I think it is, and in over Africa. Whereas in the day image, it's really those bright blue colors, especially over the desert. There you can see it really good over the land surfaces. Yes. Okay, then we have, because we just focused firstly on the first dust outbreak at 17th of March, so, and now we have had a second outbreak of dust, which also affected Europe or parts of Europe, especially southern and eastern Europe. We will show you just some pictures from this outbreak, how it affected Europe, and you see here pictures from Crete, the island, which you see in the satellite imagery here. It's really the dust gets blown across the sea right at the coast of Crete, and yeah, it looks like apocalypse and some amazing images, which I won't believe if they're not, but it's true. They happened like this, or I believe they are true. And as well, the same result with the snow even went as far up as to Russia and to Sochi, for example, where Winter Olympics 4 years ago took place. And there you see on this normal white snow, you see the orange or orange-brownish colors with the dust, which is covering the snow there. Yeah, and some amazing images. Just a quick, one of the dangers of the snow, of the dust on the snow, is if it's snowing again, or there's fresh snow falling on those dust-covered mountains, they are high risk, or it's a high risk of avalanches, because the friction of the fresh fallen snow is really low with the lower already fallen snow or dust on it. So there's a high potential for avalanches, which are of course a risk for tourists and also for structures in mountain regions. So do we have one more image here? It's another image, the air mass RGB. You can't see that much in it, just to show it. You see once again the sandstorm, the sand forming here, or the outbreak, which is seen across Algeria here. So that's it from my side. Thank you. And we will switch again, so short break.
Okay, so hi everybody from my side as well. My name's Philipp, and I'm going to tell you a little bit about the lake effect occurring mid of March in connection with the cold air outbreak that Peter mentioned before. First of all, I have a little animation here showing you the general pattern in the mid to upper atmosphere. That's the isohypsis of the 500 hectopascal plane and the temperatures. And we see here as Arne mentioned before, a trough extending here from the eastern Atlantic down to the northern African coast, with I would call it a center right south of Ireland, and a high pressure system just east of Iceland. So we could say it's a high over low situation. And in connection with the low pressure system on the right side here, like over western Russia, very cold and dry polar air masses are advected in southern direction over Scandinavia, and then turning east right over the Baltic Sea here towards like Denmark and North Sea. I will start the animation now. I will play it twice for those who may not have a very good internet connection. I hope you can all see it. And let's go. It's just three images. So we see that the cold air advances over time. It's starting at March 17, 0 UTC, and it ends this animation at Sunday, like March 18 UTC, March 18, 0 UTC. That's good. So it is. And we see that the the cold air is getting advected over the Baltic Sea and then over the North Sea, and yeah, exactly, which is supporting the lake effect coming up. The next slide, I just wanted to show you very quickly the surface analysis of the German Weather Service. We see this, the high pressure system is at the surface is located a little bit to the east than compared to the upper atmosphere right over Scandinavia, with a I would call it a low pressure belt extending here from southwest of Iceland all the way down to Brittany and France, resulting in a pretty strong gradient between the high pressure system over Scandinavia and the low pressure belt, which supports quite strong easterly winds over the Baltic Sea and also over the North Sea. And since this are very cold air masses, I'm going to try to explain how the lake effect or what ingredients are needed to for the lake effect to happen. So we need a quite warm water masses, and on the next slide I will show you the water temperatures of the Baltic Sea. So we need a relatively warm water surface and cold air getting advected right above it, so that we have a quite unstable situation, dry air masses over cold over warm water, which then results in convection and also in mixing, and the dry air really sucks up all the heat and the moisture. As the air gets advected over the warm sea, it, as I said, it collects, so to say, all the moisture, and if it reaches like land, two things come into there are two things interacting with each other. One is the surface friction. When the air moves over land, it slows down due to the surface friction. So we have a convergence here, and the other thing is the air gets lifted due to topography. So we have two things that create convection and start triggering this lake effect, which can then result in pretty heavy snow showers. So we see here in this little map on the upper left corner the high resolution visible cloud RGB. You can already see that there are really nice shower clouds here and also over the Northern Sea. We have later in the presentation we see a webcam picture of Rostock, and here are two radio soundings, one from Greifswald and one from Schleswig. And I just want to mention it shortly. We have a water temperature over the Baltic Sea, in the Baltic Sea, of 2 degrees, and a surface temperature, air temperature in Greifswald of -1 degree. So that is 3 degrees different, 3 degrees colder than the water. And we see a pretty big spread for now. Like the dew point is -10 degrees, so we have a spread of 9 degrees. And if we do now a evaluation of the cumulus convection level, we see that the general cloud base is about 1,300 meters above ground, and due to the very dry air masses aloft, like 850 hectopascal, the clouds are not very thick or high-reaching. They're just like 200 or 300 meters high. And as we see that the air getting advected westwards and reaches Schleswig, which is located here, we see that the cloud base is descending, since the air in the boundary layer is getting well mixed, so and sucks up, as I said before, the moisture from the water and gets mixed, so the cloud base descends to approximately 700 meters, and the cloud tops, due to the convection, they rise to about 2,300 meters. This is generally not a very high-reaching cloud for convection, but given the very cold temperatures and in combination with the relatively moist air, this is enough to produce for this region some significant amount of snow showers. Okay. Let's move on. Here we have the high-resolution cloud RGB, a little bit larger, with the sea surface temperatures. I just marked them. Here we see the 2 degrees of the Baltic Sea, and we see that the North Sea is even warmer than the Baltic Sea, quite a bit, and that this is also reflected in the much more dense clouds, and just much more clouds than over the Baltic Sea, over the North Sea. So we see that the North Sea is about 4 to 5 degrees, and the clouds are getting thicker and higher. I see that is an animation as well, so we can see the evolution of the cloud streets of the lake effect. So for explanation of the colors of this image, this is the high-resolution cloud visible RGB, where yellowish colors that you can see here are also here over the Baltic Sea. They represent low or mid-level clouds containing water droplets, since the red and green channel in this RGB are combining the 2 high-resolution visible channels, and the blue channel is the inverted 10.8 micrometer channel. And since it is inverted, where the cloud tops are warm, there's a low contribution of the blue channel, and where the cloud tops are cold, there's a high contribution, which means that we have on the bottom of the image, where we see these white bluish colors, there we have high clouds, thick high-level clouds, and as we see the animation going through, once again, we see some very light or thin blue streaks here over northern Germany. There's a very high contribution of the blue channel, which means there are very thin high-level cirrus clouds. That's just for a short explanation of the image. So now we have a little like test for you again. This is a day microphysics picture, which depends mostly on the green channel. The green channel represents the near infrared channel of 1.6 microns, and we see that snow-covered areas appear in magenta, and the reflectivity in this image in the 0.87 micron channel has a high reflectivity in the red color beam. So that is because the snow crystals absorb a lot of the 1.6 micron radiation, so they don't reflect that much in that channel, which gives a. Oh, I'm confused now. I'm sorry. Yeah, approve. Okay, so what I want you to try now, maybe you can do it better than me, is to guess where in this is a RGB color selector tool where you can adjust the colors to recreate the colors that you see in the image. And I want you to choose where the green color selector now would be. I would give you the solution. Okay, I give you the annotation right now. Okay, you're already doing it. Yeah, okay. I'll give you some more time. Okay. Yeah, some people are still trying, I see. Okay, that looks good. You guys are better than me. I will stop it now and give you the solution. So most of you are, yeah, they get it quite good, quite right. On the right side of the image, the green contribution of the green channel is quite high, and it is reduced on the left side since there are more ice crystals in the clouds that absorb the 1.6 channel. So the red and the blue one almost stay the same, but the green one is reduced quite drastically since there are more ice crystals that absorb that 1.6 microns radiation. Exactly, that's how it was. I'm sorry for the confusion. Okay, but as you see, you guys did quite well. So the red and blue one stay the same, and the green one is reduced quite drastically. Okay, the next satellite image is a natural color RGB from the American Suomi NPP satellite, which happened to cross Germany at this time, and we see the cyan color of the on the left-hand side of the image is more pronounced than over the Baltic Sea. That is again due to the ice crystals, which reflect the red channel more than the water droplets in the clouds of the Baltic Sea, which occur more whitish than on the cyan color here. They occur white since all three channels have an almost equally contribution to the image, and if you mix all the three colors, as you can see on the lower right, you get a whitish color. And here we have a larger lower contribution of the red channel, so the green and the blue channel result in this cyan color. So now I'm going to show you just quickly a radar image of the cloud streets. So that's just for evidence that it's not just clouds developing, but also precipitation, in this case snow shower, developed. And to conclude, I've just showed, as I said before, the webcams from Rostock. We see these cloud streets here going along the wind direction, the mean wind direction. These cloud streets are not fully understood yet, but as a conceptual model, you can say that the friction in the boundary layer and the cold air advection above the boundary layer, they counteract in some way. So the wind, due to the friction, the wind turns right with height, and at some point the cold air advection overlaps this effect, and the wind turns back left again, since in cold air advection the wind turns left. And with this wind turning vector, some vertical roll vortices develop, and in this where two roll vortices have the same updraft direction, the cloud streets develop, and on the other hand, in the descending part, the clouds are there's a cloud-free part. Okay, that's from my side for the lake effect, and I will give back to Peter now.
So, yes, Peter again. Thank you, Philipp and Arne, for this interesting satellite images and impressions. So the time is going on, and I will show you only some short weather briefing, some information for today. This is an image from the Alps. You see snow, and the weather in Germany is cloudy today and a little rainy. We expect now in the afternoon more rain in Germany because we have here a wave, and before the warm front in the next hours bigger rain area reach us. And but the central feature is this low, the bigger low south of Ireland, and we have over the Atlantic cold air advection. In the eastern parts of Germany, it begins here in Germany and Poland. We have a more stationary front which separates very cold air mass in the northern parts, in the Baltic area, and warmer air mass in southeast Europe. You see this temperature differences here good in the H50, H50 level, with the blue colors for the cold air mass here in Scandinavia, and with the wave we have here in southern parts of Germany for a short time, or warmer air mass, and this is replaced in the next hours and in the night from the cold air mass below the cold front. The cold front, you see it here in the color change. Yeah, this is a slide of the temperature advection, and the ISO helps us in 300 HPA for the morning, and it's very good illustrated here, the warm air advection and the cold air advection around this wave. But we have also in the eastern parts of Germany and Poland also strong warm air advection of the occlusion, which extends from the pressure in the north to Germany. This is a satellite image, a water vapor image, is 6.2 from 6 UTC in the morning. And you see here in the dark areas the dry air masses in the upper troposphere region. We have sinking air masses, and this is a good hint to have a look to the jet stream. We overlap the jet areas here, and you see the difference between gray and really dark. This is round about the area where the jet axis is, and you see the jet axis you see also in the air mass RGB, very good, where you have a color change from more bluish areas to red, this red area, and we have here one polar jet and one in the north. You see it also the same changing. Then you see in this image the air masses, the green air masses represents warm temperatures, and the bluish colors colder air masses. And this reddish color means that you have sinking air from the stratosphere, and this air is ozone rich. This gives the reddish color. So, and at the end, I have two slides with the RGB. You see here we need the HRE RGB, also from sunlight, and in which this is very good for a high resolution. But the problem, if you see this, is there is no difference between snow areas and lower clouds, lower or medium high clouds. They all appear in yellow colors. For example, you see it here in Norway, a lot of snow, but also you have here in the northern sea yellow clouds, and it is not so clear, the difference. But if you switch to the snow RGB, there is a big plus point in this RGB for the difference. You see in clear orange colors all areas with snow, perhaps in all mountain areas, Pyrenees, in Norway, and also in the Baltic Sea, where perhaps here in the islands of Åland you see there is ice on the water, and the clouds are more brighter orange color. So you have a better difference between these two features. So, and the last point is, Easter is coming on the next weekend, and I have only one slide for the Easter Sunday. And now we are not so happy in Germany because on Sunday we get the next cold air outbreak from Scandinavia. So you see in the colors represent the H150 HPA, and I wrote some points here on the map. This is the temperature maximum for the Sunday. In Germany, around about 8 degrees in this cold air mass. In the northern Scandinavia, only 0. But I saw there are some colleagues now from Italy, from middle of Italy, in the Mediterranean area and Spain. It's warmer, around about 15 to 20 degrees. But also not so stable. There are some troughs here in the area, and also you have a risk of rain or rain showers. But the warm area, a good area, is in the eastern part of Europe. On the eastern part of this low, we had a warm air advection and perhaps more than 20 degrees. So we all together, we all 7, wish you happy Easter. And if you have questions, we will have a look in the next 10 minutes or 15 minutes to the chat box, and we'll give you answers. Perhaps you have it. So happy Easter and goodbye from Langen.